All right, let's dive in. Today, we're going to try and answer maybe the biggest question there is. What happens next? And I don't just mean next year. I mean a million years from now, a billion, all the way to the very, very end of time itself.
I mean, it's the ultimate question, right? And look, science can't give us a crystal ball, but what it can do is let us piece together everything we know. And from that, we can start to paint this incredible mind-bending picture of what's coming. So we're going to explore our future by zooming out, looking at it on 4 totally different scales, each one bigger and wilder than the last.
We're going to see how the very ground beneath our feet is basically on a slow-motion collision course, destined to form one giant landmass all over again.
We'll also look at the absolutely audacious sci-fi technologies that humanity is seriously thinking about to take control of our own climate.
And we're going to travel to a future so ridiculously distant, it's hard to even wrap your head around, to witness the final flicker of light as the entire universe fades into an eternal night. Okay, so let's get into it. Our journey starts right here and now, on the human timescale. This is our moment, where we're facing our greatest challenge yet and proposing some of our most radical solutions.
This number, 1.19 degrees Celsius, this is where our story begins. It's how much the world is already warmed up, and it's this urgent reality that's pushing scientists to think not just outside the box, but like way off the planet entirely.
So, with the planet getting hotter, scientists are exploring some truly mind-bending ideas to cool it back down. Welcome to the world of geoengineering, which is basically a deliberate, massive attempt to grab the Earth's thermostat and turn it down ourselves.
You know, one of the most talked about ideas was actually inspired by a natural disaster. When Mount Pinatubo erupted back in '91, it blasted so much sulfur dioxide into the stratosphere that it acted like a giant mirror, reflecting sunlight and cooling the whole planet for almost 2 years. So the idea is, hey, let's just do that, on purpose. Kind of like putting sunscreen on the entire Earth.
But hey, why stop at the atmosphere? The next idea is even bigger. We're talking about building a giant sun shield in space. A team at MIT actually proposed creating a massive raft of silicon bubbles, get this, about the size of Brazil, and just parking it out there to physically block a little bit of sunlight to cool us down.
Now, besides blocking the sun, we could also just tackle the carbon that's already in the air. And while planting forests is obviously super important, some engineers are designing these mechanical trees, basically machines that can suck CO2 right out of the atmosphere. And a single one of these can do the work of 1,000 real trees.
But let's say we actually do it. We manage to control our climate. That brings up an even bigger question. Are we really in charge here? It turns out we're really just passengers on a planet that has its own, much slower, and way more powerful agenda. So now we zoom out to the planetary timescale. And on this scale, our most impressive engineering projects suddenly look tiny. They are completely dwarfed by these immense geological forces that are constantly reshaping our world, whether we're here to see it or not.
Yeah, on this scale, things that seem impossible become pretty much inevitable. In about 10,000 years, this nice warm period we're living in could end, maybe tipping us into a new ice age. Within 50,000 years, a supervolcano, like the one bubbling away under Yellowstone, is statistically likely to erupt, with enough force to change everything. And if we look 250 million years into the future, the slow dance of the continents will have brought them all crashing back together, forming a brand new supercontinent.
And of course, you gotta love the internet because it has already come up with the perfect name for this future landmass. It's really hard to top Pangea 2 tectonic boogaloo.
But even a supercontinent is temporary on a cosmic scale. So, zooming out again, we realize the fate of our entire planet is tied to the life and eventually the death of a single star, our sun.
This is the unavoidable story of our planet's end. As the sun gets older, it just burns hotter. In 2 billion years, it'll be so bright, it will literally boil Earth's oceans dry, sterilizing the whole planet. A few billion years after that, as it runs out of fuel, it's going to swell up into a red giant, a monstrous expanding star that will physically swallow the inner planets, including us. All that's going to be left is a tiny, dense core called a white dwarf. Basically, a stellar corpse, just cooling forever in the dark. But you know, even the death of a star is really just a local event. For our final act, we have to zoom out as far as we can possibly go, to the cosmic timescale, where we'll witness the beginning of the end for the universe itself.
In about 100 trillion years, the universe will enter what's known as the degenerate era. The gas clouds needed to form new stars will be all gone. Every single existing star will have burned out, leaving behind only their cold, dead remnants.
The whole universe will just become a dark, silent, cosmic graveyard.
And the end, it isn't a single event. It's just a slow, fading series of eras. After the last star dies, even matter itself will start to decay, leaving a universe populated only by black holes. But they're temporary too. Over timescales that are just impossible to comprehend, even these cosmic giants will evaporate, until absolutely nothing is left but a cold, empty void.
So, from planetary engineering all the way to the final evaporation of black holes, we've basically journeyed to the end of time itself. And after all that, you have to ask, is that it? Just an empty, silent nothingness?
Well, maybe, but thinking about these immense dark futures brings an incredible sense of perspective, you know? It brings you right back to here and now. Against the backdrop of trillions of years of darkness, this quote really hits different.
When you really consider the vast, cold, empty future of the cosmos, it makes you realize something pretty profound. Our brief, chaotic, and vibrant time, this tiny little sliver of cosmic history when stars are still shining and life exists, it isn't just a fleeting moment. It's the brightest moment the universe will.
Ever wonder what the far, far future holds for Earth? Let's take an absolutely epic journey through time. We're going to zoom out, way out, from right now to the literal end of everything. So we'll start with the next 100 years, then jump millions and even trillions of years ahead. Okay, let's start with right now. The data's clear, our planet is heating up, and fast. But it's not all doom and gloom. In just 100 years, we'll likely be heading for Mars. So what about 1,000 years from now? The San Andreas Fault could see this many major quakes. Zoom out 10,000 years and you'll see Earth's own power at work, reshaping even Niagara Falls. And, some of those rhythms are, well, incredibly violent. Think supervolcanoes. Yeah, these things are expected every 50,000 years or so. A bigger threat than asteroids for sure. Fast forward 250 million years, and the continents themselves are going to merge into one giant landmass. So, faced with all this, what could humanity even do? Well, the ideas get pretty wild. I mean, we're talking mechanical trees, giant underwater curtains, and even massive rings built in orbit. We could even create our own volcanic eruptions. But yeah, messing with the weather is a huge gamble. Or, get this, a solar shield in space. To work, it'd have to be the size of Brazil. But no matter what we do, Earth's fate is sealed by our sun. In 2 billion years, it'll boil our oceans. And it's not just our solar system. In 4 billion years, our galaxy is going to crash into Andromeda. Okay, now for the really long view. After the last stars burn out, the universe gets weird. Basically, nothing's left but black holes. Just these gravitational titans in an endless, empty space. But even they won't last forever. Thanks to Hawking radiation, they'll slowly just evaporate. As the very last one disappears, it'll create one final flash of light. And then, just nothing. So after that journey to the end of time, it kind of makes you think, huh? Makes you appreciate